Let's take a few moments to look around you. You see many things, correct? You see both man-made things like the furniture and gadgets, and then when looking outside, you see the natural objects like flowers, trees, pebbles, and much more. First, let us focus on the nature before coming to the man-made objects and see if there is anything special in its creation or design. Well, it is obvious that the things you see in the nature has a certain size and shape. Have you ever thought of how the same type of flowers have similar shape no matter whether it is grown in the garden at the front or in the backyard? And how much you appreciate the beauty of these flowers when compared to a stone or a plant in your garden. Look at the seasons you experience, like summer and winter. If you observe, there is a pattern that our nature follows to make it come and go at the same time. And flowers and trees behave similar year after year. So how can nature remember the pattern to be repeated at definite intervals? Does nature use mathematics to decide the shape, size and these patterns in the objects that we see around? Let us try to understand the creation of a flower by nature and what calculation has gone in the design. Before we look at a flower, let me tell you a set of numbers which has an interesting relation between them. Have you seen this series of numbers? Do you see any relation between these numbers? If you look at closely, you can see the relation. The numbers are formed by adding the previous two numbers, like 1 added to 2 gives 3 and 2 added to 3 gives 5 and 3 added to 5 gives 8, and it goes on like that. The series is called the Fibonacci series, and also there is a citation of this series in the Indian Vedic mathematics system. At this time, just remember that this series of numbers has a very special role in nature and in our science and technology also. Now, how nature uses this number series? If you count the petals in the flowers that you see around, you will find that it is a Fibonacci number like 3, 5 or 8. Do you want to try with some of the flowers in your garden? Again, let us look at a unique shape that we can form by the Fibonacci numbers. If you draw an arc along the outer corner of the squares formed by the side lengths of the Fibonacci numbers as seen in this picture, you get this spiral shape. So what is so special about this spiral shape? Look at the shape of the snail shells or even the curvature of your ear. Many of the natural shapes that you see here, which are naturally formed, follows this spiral shape. I believe you can appreciate how this mathematics is used by nature. Now let us take a close look at how the seeds are arranged in the sunflower. It's found that the count of the spirals in which the seeds are arranged as shown in this figure is always a Fibonacci number. Again, if you are interested, take a look at the tree near you and see how the branching off follows as a Fibonacci series when the tree grows. Look at the seasons that come and go in regular intervals. We have a pattern there too, correct? The seasons of summer and winter happens because of the tilt of our earth axis as shown in this figure. But then with the amount of sunlight falling being different at different places due to this tilting, see how the wonderful seasons come and go. So there is a relation between the angle at which the energy, both light and heat from the sun, falls on Earth's surface and decides these climatic conditions. Well, again a relation in mathematics, correct? Now let's come to the man-made things. Let us try to understand the design of very simple things that we see around us, or we have done with our hands. I believe all of us have played with the paper planes in our childhood. So try making a paper plane and see how the mathematics plays a role there. Think about the calculations you made while making the paper airplane to make it fly. So somebody would have taught you how to fold the paper using some calculations like fold the paper into half, then fold the top part along the half line, isn't it? Do you want to try making a paper plane without any of these calculations and see how much it can fly? So while human beings design things like the chair or the electronic devices that you're using, or the complex things like the car or the airplane, a lot of mathematical calculation has been applied in the making of it. And while these things work also, a lot of mathematical principles are used by the scientists and engineers to make it do what it is supposed to do. Let's take the example of a car, which was designed using the mathematical calculations to determine the engine power, the size of the car, that is the width, breadth and the height, and also the calculation that went behind the size and shape of each and every component of the car. And once the car is on the road, the amount of petrol that should go into the engine when you speed up the car, or also the force with which the car need to be stopped while you apply the brake on the brake pedal, all these involve mathematical calculations that engineers considered while designing the car. Now think about the airplanes that fly over the oceans and the spacecraft that goes out into the space and even to other planets like the Mars. You can imagine how much complex mathematical calculations was involved. Some of those we will try to understand in this course, of course. So mankind was able to progress through the discovery of things such as the gravity and magnetism, and even invention of things like electricity. And our scientists and engineers made great products like these airplanes, all with the help of knowledge of mathematics and applying this science and technology. So is mathematics used only in the design of things, either natural or man-made? No. Even the art forms that we create, like dance, music or paintings, use mathematics. Let's try to draw a smiley on a white sheet of paper and think about how much you have applied your maths in it. The shapes you used to draw, the face and the eyes in the same line, and the care you took to draw the nose at the center is all about mathematics, or specifically the geometry in mathematics. Though we doesn't think much about a mathematical calculation while drawing these, think about how these mathematics get applied in the great paintings that the world appreciate, like the Mona Lisa painting, the portrait of a woman drawn by Da Vinci. The painting is still studied for the enigmaticity of the facial expression and the subtle modeling of the forms. So where is the mathematics in it? To understand the mathematics behind most of the beautiful art forms you see around, you need to understand a unique concept called golden ratio, which is nothing but again dividing a number in the Fibonacci series with the previous number. So when you keep dividing the numbers in the series like this, you will find that the result gets closer and closer to a number called 1.618, and this ratio has some big impact on many art forms. Again, let's take a look at the Mona Lisa painting. You can find that the golden ratio is followed in the portrait dimensions, which is why it becomes aesthetically appealing to your eyes. In photography also, the golden ratio is followed in many renowned photos which you come across, which is appealing to your eyes. You can find that many of the great architecture marvels like the Greece Palace also makes use of this golden ratio in the design of it. And coming to music also, let's have a look at how the music uses mathematics. Elements in music such as rhythm, form, pitches of the note and the tempo of the tunes is related to the measurement of time and frequency, and involves a lot of mathematical calculations in defining it. Understanding these elements of music is beyond the scope of this session, and hence let's look at one of these and see how mathematics plays its role in the music. Let's take the case of rhythm of music. Rhythm in music is the placement of sound in time. You can feel the rhythm of a music or song by observing the musical sounds and silences that occur over a period of time. Let's listen to a music clip to understand how the variation in rhythm can change the way the music comes to our ears. In 2004, a computational scientist, Mr. Gottfried, discovered that in almost all the traditional music in Eastern or Western, an mathematical algorithm, which we call as the Euclidean algorithm, is followed in the rhythm. The Euclidean algorithm is a logic to find the largest divisor given two numbers. So the same algorithm or the same logic of the algorithm is followed in the creation of almost all the musical rhythms in the traditional music, such as the classical, jazz, Bulgarian, Turkish or Persian music. And what about dance? Take any dance form, most of the postures that you see are characterized by three angular notes, the linear formations like straight lines and the circular patterns, which is essentially the geometry or shapes in mathematics. In some classical dance forms like Bharatanatyam of India, it uses the cardinal numbers 3, 4, 5, 7 and 9 to arrive at a figure of 32 through various permutations and combinations to represent the body postures. Now that we have seen the way mathematics is used by nature and also in our man-made things, let's try to understand the subject called mathematics in the next module and see why it is important for each of us in our day-to-day life. Till we meet again, enjoy the mathematics.